Okay guys, welcome back once again, and today we have these two questions. This try work to try. So let's jump straight in and see what we have. If y is equal to x over s squared plus 5, you are supposed to show that what this equation is true. You are supposed to show that s squared, let me just put it in red marker here, so that those who want to try can start before we jump straight. S squared plus 5, double derivative, plus 4x derivative d dx plus 2y is equal to 0, right? Okay, so that's what we want to show. So let's come back to our question. Okay, so if you have this, you just multiply through by what the LCM, which is s squared plus 5. So that will give me s squared plus 5 multiplying y is equal to, let me just take all this out, it's equal to what? X. So I'll differentiate through 10 by 10. Okay, I'll consider this one as a product. This one is one function and this one is another function. So if I consider it as a product, I'll maintain s squared plus 5, differentiate y, I'll get what? Dy dx plus, that's the implicit root 2. You can also take it as implicit in how you want to do it. Then I'll maintain my y now, and I'll differentiate the bracket. I'll get what? 2xy. I'll get 2x, sorry, and the y is there, so it multiply. So let me just write it 2xy so that to make it nice. So I'll get 2xy is equal to, if I differentiate the x, I'll get what? 1. So I need double derivative, so I'll differentiate through again. So that's going to give me, this one is also a product, so I'm going to maintain it as a product. So I will maintain s squared plus 5, differentiate dy dx, and I'll get double derivative of that, plus I'll maintain dy dx, and I'll differentiate the inside. When I differentiate the bracket, when I differentiate this one, I should get what? 2x times what? The dy dx, plus this one too, I'll consider it as what? Product. I'm going to use what? The implicit rule or the product rule. And then how you want to do it, you will still get it. So I maintain 2x, differentiate y, dy dx, I'm okay. Then plus I maintain 2y, differentiate s, I'll get what? 2y, which is equal to what? 0, because if I differentiate 1, I'll get 0. So this is just what? S squared plus 5, second derivative, then plus this will be 4x dy dx plus 2y is equal to what? 0. And this is the same thing as what we are asked to prove. This is just equal to this. So we have shown that this function is equal to this. Are we okay? Okay, good. So let's jump straight into the what? To the second equation. Let me just chop my word off. Right. So the second one is giving us that if y is equal to x over x minus 1, we should show that x minus 1, second derivative, d square y over dx squared plus 2 dy dx is equal to what? 0. Okay, let's jump straight in. So if you multiply through, you get x minus 1 multiplying y is equal to what? X. The same thing, product. So I'll maintain x minus 1, differentiate y, dy dx, plus I maintain y, differentiate this one, I'll get 1 is equal to, when I differentiate s, I'll get 1. Okay, Then I'll differentiate again, second derivative. This is also a product. I'll maintain x minus 1. Differentiate dy dx. I'll get the second derivative part. Plus, I maintain dy dx. I differentiate this one. I'll get what? 1, which is still what? Dy dx. Plus, I differentiate y. I'll get what? Dy dx. If I differentiate 1, I'll get what? 0. So finally, I'm going to get something like this. Let me bring it to the top. Let's continue at the top here. I'm going to get, change my color. Q. I'm going to get x minus 1. Double derivative dy d square s square plus dy will give me 2 dy dx is equal to what? 0, which is the same thing as what they asked me to find. And the same thing as this. Okay, so that is it. So that's how we go about proving these such questions. Are we okay? I hope you guys are okay. Alright, if you have any question, any comment, let me know in the comment section below. Please, if you have not subscribed yet, do so. Alright, see you guys in the next video. Thanks for watching. Take care. Bye.